Hi everybody, welcome back to the channel. In this video we're going to be talking about something called Newton's method, and what this is going to help us do is we're going to be able to solve problems that are more difficult, more complicated, that we haven't seen before. Specifically, when I say solve, I mean we're going to be able to find zeros of functions that are more complicated. So start out, let's take a look at an example. We're going to start out with this function here. F of x equals x to the third plus 2x squared minus 5. Now I'm choosing this example for a couple of different reasons. First of all, it's a cubic, and something you hopefully remember is that every cubic has at least one real zero. And also, I'm choosing this one because the cubic does not factor very easily. Alright, if we had a problem where we could just factor it easily, we already know how to deal with that. If I gave you a quadratic, you already know how to deal with that because you have a quadratic formula. But if we have functions that are more complicated, it's not so obvious how to be able to solve something like x to the third plus 2x squared minus 5 is equal to 0. Okay, that's pretty tough. Now, it turns out that there actually is something called a cubic formula, but it's pretty messy, and that helps you solve any cubic. But most people will have never seen that cubic formula in their life. Okay, and as functions get more and more complicated, most functions that are even tougher than that, there's not any way to always know exactly how things are, how that's going to solve, depending on what you're starting with. So one thing you might think about is, if I don't know how to solve this, could I go graph it? Okay, and I think what you'll find is if you graph it, it looks something like this. And this does have one x-intercept, not 3, by the way, just 1 on this one. And it's somewhere between 1 and 2. Okay, it's like 1.2 something. You could probably go use your calculator, by the way. I think some of you know how to go and use your calculator and use the second trace command on your calculator and use the zeros option and be able to find that. But we're kind of thinking about how could you do this by hand. And by the way, it's also good to know what is your calculator doing behind the scenes. Okay, your calculator uses a few different methods that are similar to Newton's method that help you find the zeros there and that actually give you the decimal versions. And so we're actually looking at kind of what is some of the details of what is your calculator doing behind the scenes to be able to solve this. Okay, so let me draw a picture that's a little bit bigger. Let me blow this up just a little bit. So here's what we're going to see on this page. Let's look at something very similar to this. So let's say we have this function over here. And what we're going to do is this. We're going to pick, so what we want to find is this x value right here, but the problem is we don't know that. And it's some kind of decimal, it's not very friendly. Okay, what we're going to do is we're going to pick a starting point. We're going to call that starting point x1. And x1, sometimes the x1 is going to be given to you and you're going to be told, hey, start with this value. And sometimes you have to kind of look at the function and look at where the 0 is and decide what you want to use for x1. But that takes a little bit of practice or a little bit of experience to know what are you looking for. So let's see what we're looking for. So find x1 and then go up or down until you hit your graph. In this case, we're going to need to go up. So go up until you hit your graph. And what we're going to do is this. We are going to look at a tangent line to the graph at this point. So the tangent line might look something like that right there. Okay, and we're going to take a look at where does this tangent line cross the x-axis. So that would be right here. And what that point is going to represent is what we are going to call an x2. So x1 is kind of our first, call it a guess, I guess it's our first guess of what we think a solution might be, or at least a number that's close to our actual solution. Okay, and then we're going to look at a tangent line and say, okay, where does the tangent line cross the x-axis? That's going to give us x2. Now x2 is another guess, a second guess, and probably, most of the time, not all the time, but many times, x2 is going to be closer to the actual answer than x1 was. Okay, and so then we're going to kind of repeat that same process. Take x2 and go up to hit the graph, and then look at the point on the graph that has x2 as its input, and then go ahead and do the same thing we just did earlier, which is look at the tangent line, and where does that tangent line cross the x-axis. Okay, where the tangent line crosses that x-axis right there, now we're going to call that x3. Okay, so we have an x1, we have an x2, we have an x3. Now take x3 and go up until you hit the graph, and then look at the tangent line to the graph at x3, and the point that you find of where that tangent line crosses the x-axis, that's going to be x4, and so on and so forth. And you can do this a lot of different times, and what you're hopefully going to see, depending on the function that you're starting with and what x value you started with, but what you're going to see is that as you move along, you are going to get closer and closer and closer and closer to the actual answer. And I could keep zooming in on this and zoom in and zoom in. And what you'll see is if I can zoom in kind of finely enough, I could keep drawing these tangent lines, and eventually I'm going to be getting like closer and closer and closer to that actual point. And eventually I might only be off by that point by like 0.00001 or something like that. I might be like so close to that point that as a decimal I can barely even tell the difference in their x-coordinates. Okay, this is something that's known as an iterative process. An iterative process means you have something that you're going to kind of do over and over and over and over and over again until you get close enough to be kind of within reason, or close enough to be within a certain number of decimal places that you might want. Okay, and I mentioned that your calculator does something like this behind the scenes. Your calculator, when you use that 0 command, it doesn't actually give you kind of the exact answer. What it's giving you is a decimal approximation of that number, and it could be correct to a certain number of decimal places. And the more decimal places you want your calculator to be correct to, the more it's going to have to do an iterative process like this. And it's not just going to have to find x2 and x3 and x4. You might need to find x5, 6, 7, 8, 9. And the more exact you want to be, the more precise you want to be, the more you need to do this. Okay, so what does that process look like? What do we mean do this, right? What do we have to do over and over and over again? Well, remember we're looking at a tangent line, and so we're looking at the equation of a tangent line, which looks like y minus y1 equals m times x minus x1. And you can think about, as is the case with any kind of a line in here, but here's the deal. This x1 is going to be the starting point, or I tell you what, let me call it this. Let's call it a first guess. And as I said earlier, sometimes you're going to be given this, and sometimes you need to kind of think about what a good first guess could be. But instead of calling this y1 and m, I'm going to relabel those things based on kind of what we know we could call them. So let's call it this. Let's say y minus f of x1. Just going to replace a y1 with an f of x1. And instead of calling it m, I'm going to call it f prime of x1. And this is times x minus x1. Okay? So we have an x1, we have an f prime of x1, and we have an f of x1. Now let's go back and look at our x-intercepts over here. All these places where our tangent lines cross the x-axis. That's what we're trying to find. And when you try to find those, what we're really looking for is where the y-coordinate is equal to 0, right? I mean, on the x-axis there, your y-coordinate is always 0. You're not going up or down at all. And the question is, well, what is your x value? So what we're looking to find is what happens when you plug in 0 for y. And the question is, in that tangent line, what do you get for x when you plug in 0 for y? So go ahead and take a second and solve for x here. Try to get x all by itself. Okay, it's going to look something like this. Divide both sides by f prime. So you get x minus x1 on the other side. Now to get x by itself, add x1 to the other side. And if you add x1 to the other side, what you get is this. You get x equals x1 minus f of x1 divided by f prime of x1. Okay, remember, x1 was our first guess, something that we thought was close. Now this x over here on the right side, that's not going to be the exact answer or the exact 0 of our function. What that is going to give us is where does your graph of your tangent line cross the x-axis. So really this x right here, this is actually more like our second guess, which instead of calling it x, we really probably should call it x2. So I'm going to kind of flip the equation here and say x2 is equal to x1 minus f of x1 over f prime of x1. And actually, if you think about what's going to happen after this, after we have a second guess, we're basically just going to start the process over again. If I go back here and I drew the blue line, okay, and then we basically started over saying, great, now I have another x value to use. Or I guess actually at the beginning it was the black line. I used the black line and said, now that I've drawn the line, I have an x value to use. Now let me kind of go up to the function and use that value x2 as the input, and then kind of basically just start the whole process over again. And so what we're going to see in the next step, if we kind of do all the same stuff, is we're going to see that x3 is equal to x2 minus f of x2 divided by f prime of x2. Okay, it's all the same steps. You're just kind of relabeling what you're calling x1. Now you're calling it x2, and you're just using a different input. And you can kind of get the idea, as I said earlier, called this earlier an iterative process, saying do the same thing over and over and over again. And so when you go find x4, it's going to look like x3 minus f of x3 divided by f prime of x3. And so if we were to kind of generalize that, here's kind of what this looks like. If you want to find a next guess, which I'll call an n plus first guess, all you need is the guess before it. Like, what was the guess that you just had as your last guess? So this is going to look like x subscript n minus f of x subscript n divided by f prime of x subscript n. Okay, and you're basically just going to kind of keep doing this over and over and over and over and over again. Now, the nice thing about this is that f and f prime, all those relate to is your original function. So those aren't really changing as you go. If you know what your original function looks like, then you still have f and you still have f prime in exactly the same way. Okay, so let me go back to the example I had at the very beginning. We said that f of x is equal to x to the third plus 2x squared minus 5. And it should be pretty straightforward to find f prime of x, which is 3x squared plus 4x. So earlier what I said is that I want to start, my first guess was 2. Now, by the way, the reason I picked 2, I think I mentioned this, but the reason I picked 2 is because 2 was the whole number that's pretty close to the actual 0. I also could have picked 1, and that would have been fine either way, right? 1 or 2 are both good. Those are both whole numbers near that 0 there. I happen to pick 2. And so what's going to look like, if I want to find a second x value, what I'm going to do, or a second guess, which hopefully is going to be closer than my first guess, we'll find out, the second guess is going to look like 2 minus f of 2 divided by f prime of 2. Okay, so let's see. That's 2 minus, okay, what do you get when you plug in 2 into f of x? I got f of 2 is 11. And if you take 2 and you plug it into f prime, I got 20. So 2 minus f of 2 divided by f prime of 2 gave me something like 1.45, which is good because we know the decimal, or the true answer, should be between 1 and 2. So it looks like my second guess is a little bit closer than my first guess was. Okay, let's see. Called this an iterative process. How do we keep going with this? Well, x3 is going to look like 1.45 minus, now be careful here, here's a common mistake I see. People want to do f of 2 divided by f prime of 2, but you're actually replacing that everywhere. So now it's f of 1.45 divided by f prime of 1.45. And if you calculate all of this out, I got something like 1.2638, so on and so forth, right? And you can keep going and find x4 and x5 and x6, and basically think about how far do you need to go in order to get really, really close to what you know the answer actually should be. Okay? So we're going to I'm going to have another video that has some examples as well as some calculator tricks. But for now, hope you enjoyed.